I want to talk about differential equation about damping, that is on page 26 until 31. In the lecture notes they use this equation and you should be familiar with this, becomes the auxiliary equation, and then from this we can solve the alpha. The alpha is here, the power e to the power of alpha x. So the alpha could be plus or minus here, alpha plus when this is plus, alpha minus when this is minus. And in the lecture notes they simplified it into this minus 1 over tau and gamma. Actually you can use any variables here, but I just use consistent with the lecture notes. The general equation is this, and if you want to simplify it, it's just substitute alpha positive in here, so that's minus 1 over tau plus gamma, and substitute alpha negative, minus 1 over tau minus gamma, and collect the e to the power of minus x over tau term, and you will get this equation that is on the lecture notes. Okay, and this is about damping. Like, I don't know what damping means, but in order to solve the equation, it's like you don't really need to know what is it. So it's just when it's overdamped, this root of this, well, inside of that root is more than 0. And from this equation, we will get, well, just use that equation actually. For underdamped, that is when this is less than 0. And for this case, we can take out the minus 1 from this, from the gamma. So we got root minus 1 and we flip this out. So we will get this is as a real number and I. So we can say it's I omega. And by substituting on the general equation here, we get this equation. And by using Euler's relation, we will get its cos omega x plus I sin omega x. And if you notice, this is the conjugate, so we get minus I sin omega x. Collect terms of the cos and the sine. Notice that the I is here, and I made it as one constant because I is a constant as well. So it's d cos omega x and e cos omega x. You can use this equation or you can derive it from here. For critically damped, it's a bit different. So this is when this term is 0, so the alpha is only one number. And you have to use a new equation, that is a plus bx e to the power of alpha x. This is different with the general equation, so just memorize this. And for finding the constant a, b, d, e, or this a, b, usually they give a boundary condition, and if you put the numbers in, it will be quite clear.